Brought my keyboard with me this morning. Been having some trouble. I want you guys to see what kind of trouble I'm having here. So I wanted to get out of the building this morning, but I realized that there was no escape. Oh wait, there it is. Never mind. I found it. You feel like I'm losing control. That's because I have. Control is completely lost. Oh wait, no, there it is. Never mind. Control's there. You guys are worried, right? Don't worry. I've got everything under control. So that's just what I do. Don't worry, I've got a few more keyboard puns if you're wondering. I like to press the F5 key just over and over and over and over again. Do you guys know why I like to press that so much? I just find it very refreshing. But don't worry, all these keyboard puns have given me a real complex. I'm trying to get help, but it doesn't seem to be working. Anyway, let's do some calculus, shall we? You're welcome for all that. I went to some trouble to make sure that that was possible for all you guys. So I want to make sure we're actually doing these AP test questions. If you guys want to fast forward a minute past this, then go ahead. But it's important to note this is the graph of f prime. And since you guys are going to be doing this online, I'm going to start going through these online. If you're taking the AP test, please follow along. So this is f prime, and we wanted to figure out all relative extremes on the open interval. What's happening? So anytime f prime changes from positive to negative, we're going to have an extreme. So we are negative, and then we change to positive. That means the original graph is decreasing and then increasing. So I know right here we have a min. Then we are increasing, increasing, increasing. Something happens and we're suddenly decreasing. Well, if we're increasing and then decreasing, this must be a max. And then we're decreasing, decreasing, decreasing. Something happens, and now we are increasing. If we go down and then up, this must be a min. So on this open interval, it's very critical they say open, because that means we don't include the endpoints. If it was a closed interval, we'd have two more extrema to deal with at points A and B. Those points are null and void. So what's happening here? I'm expecting two local mins and a local max. So two or relative is the same thing. One max, and two mins. So there we go. One max and two mins. All right, so here we go. On to some examples. So this summarizes the past few days in Unit 6. We are taking some antiderivatives. No need to perform all these, just recognition here. So this, the derivative of this is right here. These are 1 degree away. If I took a derivative of this, I would get 4, and I can easily make that 2. So this is a u sub. Put a dash in there. Number 2, this one looks deceptive, but this is a quantity squared, not just x squared. So I could let this be u, in which case du would still be 4, and I could multiply by a half, and this would end up being a u sub again. So that works out fine. Here's the addition of plus 1. This is a constant, and only this term is squared. This is an inverse tangent. This is an arctangent. This guy is not. Got 4x squared plus 1, but this is 1 degree away. So this is not an arctangent. The derivative of this will be 8x, and I can multiply that by a fourth to make this happen. This is another u sub. Keep in mind, arctangent is u sub. It's just a special version of it. And this, I can remove the 1/4, and I'm left with a very simple antiderivative. That requires no fancy strategy at all. This is just a power rule. So we already are getting a lot of things that look alike and can cause some confusion. It gets better. It gets even better. So let's take a look at some things we do know how to do, and then we'll run into one that we don't. So this, very straightforward, there's nothing to this. We just get e to the x plus c. And then we've got this function trapped inside, but We've got its derivative right there, or a version of it. So I can allow u to be x squared. I can allow du to be 2x dx. And oh, I can multiply by a half, and we can make this work out just fine, x dx. So we end up with 1/2 e to the u du, which of course is 1/2 e to the x squared plus c. Finally leading us to this. Now, unfortunately, these are not 1 degree away from each other. So u substitution will fail. If I let u equal 6x, then du would equal 6. But what about the x? So that would fail. What if I let u equal e to the 6x? Well, now du is going to be 6e to the 6x, and we still can't account for this guy. Well, that's because it's not a chain rule. A chain rule never produced x e to the 6x. Well, then what did? Well, this, my friends, is a product. And today we're going to undo the product rule. So we've undone chain rules, now we've got to undo product rules. So this strategy is called anti-differentiation by parts, because you're going to have to pick and choose the parts at which you apply to your antiderivative. So to reverse the product rule, it's important to look at the product rule, right? So let's look at the product rule. Let's say we have a product. Just say f of x times g of x. And we want the derivative of this product. Well, we already know the product rule. We know the product rule is the derivative of one of them times the other, addition. It's addition. And then the first function times the derivative of the second. So what are we tasked with today? Well, somebody has performed a product rule already. We have to undo it. Whew, this is going to be fun. All right. So how are we going to undo this? Well, I'm going to rewrite this, first of all. Since we work in terms of u, for u substitution, I'm going to rewrite this in terms of u's and v's. So f is going to be represented by u, g of x is going to be represented by v's. This is not very conducive to penmanship. Obviously, these can be very easily confused, so you have to be very distinct in your lettering. So then what would this be? This would be du times v plus, and then this would be what? Well, now we're reversing this, so I have u times dv. Okay, good start. And now we're going to anti-derive this, just like we would anything else, just like an equation. So I'm going to anti-derive the left side, and I have to anti-derive both parts of these on the right side. Okay, well, the antiderivative of the derivative is just going to leave me with uv. Make sure you wear sunglasses and put some sunscreen on, because the uv can be really damaging. So that's lame, I know, I get it. Equals, so I'm going to reorder this. We're anti-deriving v with respect to u. Okay, it's weird, but okay. Plus, and now here, we're anti-deriving u with respect to v. So there it is. This is going to solve any reverse product rule that we need solved. However, the problem we're going to get is going to be in terms of an integral. So what I do is I pull a little algebra shuffle here so that I can isolate one of these two integrals. It doesn't matter which one we choose really, but this one we'll find more useful since we started with the premise of u in u substitution. So I'm going to solve for this, in which case I'll be subtracting this. So I get u dv on the right side. I'm subtracting this over to here, and I'm left with uv minus the antiderivative of v du. So this is our golden rule For products, this is what we'll use to undo all of our product rules. Somebody applied the product rule and got this answer. We're going to use this to undo it. What's going to happen is that this is going to be the problem that you're given. So we're going to have to try to model every problem like this. And we know that this problem modeled like this, the answer to it is equal to this entire mess over here. This is the solution. So this is the stuff we're going to have to do to solve this piece of information. So you'll hear me say UV minus V du many, many times. So let's apply this. Let's see what it looks like. So let's go back to the example we couldn't do before. This is a reverse product rule. There's the entire rule, but here's the piece that we're using, UV and V du. So how do we attack this? Well, we have to model this using this rule, and this piece of information right here, you have to set this up. So you have to make these two choices. You are going to make these two choices in your integral. You're going to have to pick u, but now you also have to decide what dv is. Well, look at all the pieces of information we need in order to finish this problem. We don't just need a u and a dv. We need a u, a dv, a v, and a du. We need every single one of those pieces of information in order to finish this. So if I have u, I'll have du, and if I have dv, well then I'm going to have v. I need all of that. And these are the two things that you have to choose. Here's how you can make this really, really easy. Eventually, you should derive away. What does that mean? You have to pick u and you have to pick dv. Whatever you pick for u, if you took a derivative of it, and another derivative, and another derivative, and another derivative, eventually you get 0. That's how you know what your u is. This piece has to go away eventually. Doesn't really matter what dv is, but this piece has to go away. So you've really got a couple options here. But with parts, you must pick everything. So everything must be selected. It's not like u substitution. The product rule is all or nothing. There's two things being multiplied. You have to use both of them. You can't just pick parts of it and leave little parts out. It's everything. So in this expression, you have to pick one piece that's going to derive away, and then you have to pick another piece to represent your dv. Let's make a lot of wrong choices first. So if I picked 6x as my u, the derivative of 6x would be 6, and then it would become 0. The problem with that is that dv would have to be everything else. Well, I can't make dv x times e to the, because the only thing I used here was to the. So 6x would be a fail. What if I let u be e to the 6x? Well, the derivative of that would never go away. The derivative of e to the 6x would be 6 e to the 6x. The derivative of that would be 36 e to the 6x. And we keep going and going and going by multiples of 6. So 6x fails. E to the 6x fails. Well, the only thing left is x. Since I have to choose everything, and both of those combinations failed for u, that must be u. Which means dv is e to the 6x. Keep in mind, this is in terms of x, so I multiply both sides by dx because I'm in terms of x, not in terms of v. Once you've gotten this far, and you've made these two choices, the derivative of x is 1, the derivative of 1 is 0, okay, I know I've made a good choice for u. Whatever is left, must be dv, and I've picked everything. Everything has been selected. All of this is over here. Well, now du takes care of itself. The derivative of u is 1 with respect to x. And v would be the antiderivative of dv. The derivative of what gave us this? Well, certainly e to the 6x. If it was a derivative, a 6 would come out front. It's an antiderivative, so a 1/6 comes in front. And now we have all 4 pieces. This, if you guys remember, we made these 2 choices, but this is the original problem. We are modeling the original problem after that. So our solution is all of this stuff. This is our solution. So the antiderivative of u dv equals, and now what I need is uv minus the antiderivative of v du. Once I've got these things in place, I just fill in the blanks. So the x goes in for u, the v goes here, so I end up with x times 1/6 e to the 6x minus the antiderivative of v, which is right there again. Du is just 1 dx. So I end up with 1/6 e to the 6x. That's v. Du is 1 dx. And let's write this all out before I evaluate anything. So I'm just going to sneak the x in between here. I get 1/6 x e to the 6x minus the antiderivative of 1 times this is just 1. So I've got 1/6 e to the 6x dx. And we're done. We are not done. This is still telling us to do something. It says take an antiderivative. We still have to take the antiderivative. So I take an antiderivative of this. I'm going to pull the 1/6 in front of this. So I'm only left with this. Why would I do that? Well, because I already took the antiderivative of e to the 6x. It's 1/6 e to the 6x. I already did it. It's right there. So I'm going to do it again. Another 1/6 is going to come out. And I'm going to get 1/6 times another 1/6 e to the 6x. Don't forget the plus c. This guy carries along for the ride. This was subtraction, so it's minus. And I end up with 1/6 x e to the 6x. There's my answer. Let's clean this up and be done. So our final antiderivative is 1/6 x e to the 6x minus 1/36 e to the 6x plus c. We have undone the product rule, and we've taken an antiderivative. This is called antidifferentiation by parts, because there are so many parts that you have to figure out. And that's it. No, we're going to do another one. Of course we are. Okay, so let's look at another bad boy. Got all this stuff going on. Here's the key decision. What will derive away? What will derive away? So we need to model this. This will be our answer. And we are modeling this after what? Well, this piece is supposed to be u dv. So we have to make that choice. What do we think u is, and what do we think dv is? Well, certainly if I take a derivative of cosine, I'm just going to shuffle between sine and cosine infinitely, so that's a waste of time. If I just pick this as u, it will derive away. But then du would be one piece left, or sorry, dv would have to be 3x cosine. Well, cosine of what? Well, 2x is already in there. I can't let u be just the inside of the cosine, because dv has to be everything else. When you set this up, you must choose everything. So versions of the cosine are going to fail for u. It must be this piece. U must be 3x. Well then dv is the rest of it, because I have to use everything. So cosine of 2x dx is everything else. And now this takes care of itself. Du is now 3 dx. And the antiderivative takes us back to v. The antiderivative of this, a half would come in front. Not a 2, but a half. And then the derivative of this is negative sign. The antiderivative is positive sign of 2x. Looks pretty good. If I derive this again, I'd get 1, and then I'd get 0. So I feel pretty, I'm sorry, I'd get 0 right away. So I feel pretty good about this. So let's fill in the blanks. I need to fill in those blanks. So u times v is going to give me 3 halves x sine of 2x. That's uv minus, and then I need the antiderivative of, well, what does it say? It says v du. Here's du. There's v, so it's going to be 3 halves sine of 2x dx comes along for the ride. And there's the rest of my rule, v du. And now we have one more antiderivative left to take. I've got to antiderive this. Well, the 3 halves I can pull in front. The antiderivative of sine is negative cosine. So let's not jump to too much in our heads. I'm going to recopy this. 3 halves x sine of 2x minus, let's pull the 3 halves in front. So we have just this guy. And now the antiderivative of the sine is the negative cosine. And I'm going to need a half to come out front. So I'm going to have 3 halves times negative half, it's a negative sign, cosine 2x plus c. This is minus. So minus a negative will become plus. 3 halves times a half will be 3/4 cosine of 2x plus c. And of course, bring this guy down. 3 halves x sine of 2x. Simplified, simplified, antiderivative is evaluated. Here is our undone product rule. So far, so good. This is easy, right? Of course it is. One at a time, one at a time. All right, so here's a couple more. Why don't you guys take some time at home. I'm going to pause the video. When you guys come back, I'll have the answers up on the board. So I'm going to count down, 3, 2, 1. You give these a try, and then come back and check and see how they go. All right, 3, 2, 1, go. All right, so I put up all my work for the first one. Just the only thing you really need to be careful of here are your signs, S-I-G-N, positive or negative. Got a negative here, so this ends up being a double negative, which is positive. The antiderivative of sine is negative cosine. Don't forget about the little baby chain. So that's where the 1/5 come from. And when I antiderive this, the antiderivative of cosine, which became positive because this negative canceled that, well, that's positive sign, so this stays minus, and another 1/5 comes out, giving us 1/25. All right, and then number 2, I went as far as I could. I set up my u and dv the same as this. It's almost the exact same problem, right? With one minor issue. Once I do my uv minus v du, well, I've got another product rule here. Man, what does that mean? I've got another product rule. Well, guess what we have to do again? Cover this thing up, and now you're left with basically what you started with. You have another product rule. You got to go for round 2. This was actually round number 1. We've got to attack this all over again and do round 2. We've got to start with just this problem and do a UDV all over again. U is going to be 2/5 x, du will be 2/5 dx, dv is going to be the cosine of 5x dx, which means v, antiderivative will be sine. Don't forget about the chain. So we end up with this. And we've got to do parts all over again. We'll bring this guy back in a little bit, but we got to finish up the right side. So again, I do u times v. 2/5 times 1/5 is 2/25. So I end up with 2/25 x times the sine of 5x. And hopefully this time I'll get something that's not a product. Minus v du. There's v, there's du. These are both positive. So I'm just going to get 2/25. Okay, the variable's gone. I got a lot of forehead that I could brush sweat off of. I just picked the front of it. And then I've got sine of 5x dx. Oh, still not done. I have to antiderive this. I'm going to do this in one step. Follow my logic here. Another 1/5 is going to come out. So I'm going to have 2 over 125. And the antiderivative of sine is the negative cosine. So this is going to become plus. So I end up with plus 2 over 125 cosine of 5x. We'll deal with the plus c in a second. This is going to come along for the ride, but we are not finished with this nightmare yet. Because all of this is being subtracted. We just broke this down and redid our integral, so all of this is right here. We need to bring this stuff back, and remember we are subtracting, so this is 1/5 x squared cosine of 5x minus all of this. So after round 2, my goodness, but that was round number 2. We are finally finished. There are no more integral symbols in this. Let's just be very careful with our signs. So as I write this out, once again we are recopying x squared cosine 5x. This will now be minus 2/25 x sine of 5x. This will be minus, because we're subtracting the whole quantity, so minus 2 over 125 cosine of 5x. And now, finally, Connor, are you watching at home? Favorite moment, plus c. There we go. Our final answer. Ooh, I thought these things were supposed to condense. Well, with U substitution they do, because it's a chain rule, so the chain goes away. With products it's a nightmare. But there's a faster way to do this. Now I've got you on the edge of your seat for tomorrow, right? No, I do. I know. I get it. But there is a much faster way to do this. We will run into some issues, but there's a faster way. Alright, so this is your homework. You should be able to do the last 4 on this worksheet now. The first 4 problems are inverse trig. Those are the arctan problems that you guys worked on a couple days back. And this involves the new, fun, awesome strategy of UV minus VDU. Have some fun. You guys crush it one part at a time. We'll part ways. Well, actually, you know what? I'll just finish with this just for fun. Or not. Or not. Oh, there we go.